This is an ARM workstation with 128 CPU cores. For $4,399, you can get a full 128 core system with 96 gigs of ECC RAM. And sure, this CPU is a couple generations old now, but that's still a lot of grunt if your workload can use all those cores. Traditionally, these workstations were geared towards automotive development, since cars run on ARM CPUs, and this could emulate like 64 cars at a time for testing. ARM is also efficient for like web services, enough that Amazon, Microsoft, Oracle, and even Google run ARM in their clouds. But one thing that wasn't on my radar was seeing these used for VFX work, for 3D rendering. That is, until today, because SideFX just announced a technical preview of Houdini for ARM Linux. I've run Photoshop on Windows on ARM on here before, but that wasn't super optimized, especially considering Microsoft still doesn't have any dedicated GPU drivers for Windows on ARM. I mean, I've been running GPUs on ARM Linux workstations for years, but Houdini is the first big commercial app I've seen that fully utilizes the horsepower and efficiency of these ARM workstations. It runs native in Linux, it supports CPU, GPU, and blended rendering modes, and I'll show you how it runs on this machine in a second. But first, I think the reason they did this wasn't to make me happy. I mean, I'm not a VFX artist, and I'm certainly not getting paid for any of this. I think they did this because ARM Linux is actually cheaper, but not on this machine. Let me explain. A lot of VFX houses render out their work on the cloud, and from what I've learned testing things for this video, renders take a lot of time. Like even on the fastest hardware, a single clip for a modern movie might take hours, sometimes even days. You have to simulate physics, you have a particle engine, lighting, reflections, and a lot of this stuff runs on CPU cores. But instead of building massive bare metal rendering farms, a lot of shops render their stuff on clouds like Amazon. And pricing out jobs across different server classes, ARM instances are actually cheaper and a lot of times faster than like the AMD EPYC. And yes, that includes the latest Zen 5 CPU cores. I mentioned this in my video about the Ampere 1. ARM doesn't always win on efficiency or per core performance, but they do win a lot on price. To test that theory, I worked with a Houdini engineer to run a few renders on different systems. We settled on this shark render with a shark jumping out of the water and splashing back in. Running it across a bunch of different ARM systems, you can see Amazon is cooking with their 5th generation Graviton. That 48XL instance gives you 192 cores with the best price to performance out of any of their instances. I really wish they sold those processors because I'd love to test Graviton systems in my own racks. Anyway, that's only half the story because while the EPYC is clocked higher, the Graviton chips have faster memory access and they cost less to run. A lot less, apparently. This single 3-second render would cost you $40 on the AMD instance. It's half the price on ARM. So saving money is well and good, but the reason I cared enough to talk to SideFX pre-launch about this was to try running Houdini on my machine. And you might notice that this isn't the Thelio Astra. I actually had a rough time at first on that one. That's the fastest ARM workstation that I have access to, and I could get it to launch without GPU, which, you know, that's okay, I guess. But when I tried getting the GPU drivers working, I would get crashes. I tried installing X11, but it still crashed. Then I completely reinstalled an older, more stable version of Ubuntu, and that crashed too. So in talking to SideFX, they're apparently doing their testing on an AdLink dev workstation like this one, and they haven't run their tests on the Astra yet. The two big differences are this box has fewer memory channels and the motherboard's built a little bit differently. So does that make it work? Apparently yes. First I ran a few renders, which eat up every available CPU core for hours at a time. Then I opened up Houdini and messed around in the UI. And it was definitely using the GPU for in-app rendering. GPUs apparently don't always render with the same fidelity as CPUs, so the UI is the main thing where that helps. And I'm gonna stop here because it's obvious I'm a noob when it comes to Houdini and 3D rendering. But the cool thing is more and more apps seem to be getting full support for Linux, and on top of that, ARM Linux, which usually means their code is becoming more portable. And more portable code also means other architectures might be easier to support, like eventually risc-v. Not that I think that's happening for Houdini anytime soon, but I'm just happy to see this technical preview and share it with you today. But now I need to get back to procrastinating on my open source projects. It's not every week that I crank out 3 videos on the second channel.